Hi, this is a quick video to show you how to get started with MegaSplat with your own meshes and textures. So in this example, I have a little bridge mesh that I pulled off the internet to play around with. And the first thing we need to do with MegaSplats is convert the mesh to MegaSplat format. Basically what this does is mark some data onto the vertices that the system uses to allow for the hundreds of textures. When it does this, it will actually make the mesh slightly larger in vert count in most cases, but it's a very small amount of vertices most of the time. So to do this, we basically just go to the MegaSplat mesh converter, open that up, and you can dock this somewhere if you would like, and then basically you can just grab your mesh or a root object that has tons of meshes if you want, and hit process, and then it will spit out another mesh right here, which has the underscore splat on the end of it. So if we drop this mesh into the scene, right now it has no material, it is just a mesh file, but this data has been processed into the format we need. So what we can do is give this a material, which I have already here, and this is just a standard texture with normal map material that came with the model. So we can convert that to our MegaSplat shaders. To do that, we just go to the inspector here and we switch from the standard shader to MegaSplat, and then we have two choices. We have the macro detail flow shader, which is basically a single layer shader that has support for detailed mapping, macro texturing, and flow mapping, or we have our macro layered shader, which uses the second texture channels essentially to blend multiple layers of splat map data. So if we switch this to that layer, to that shader, it will now allow us to splat map this object like we would with anything else. So to prove that, I'm going to go over to the vertex painter here, activate the window, and then basically I'm going to go select a single texture here, and you can see I can just paint that texture onto here just like if I was in working on the terrain, and everything will work. Now if you plan to use this a lot on sort of traditionally texture mapped objects, one nice thing that you can do is you have your macro diffuse and your macro normal set up, so you can texture with those like you would normally, and then you can use the albedo height array and the normal here to put your splat maps into the shader. And then what you can do is play with the layering mode and the blend mode, and select a blend mode. So if you're in overlay or multiply, then if you have a gray texture and a normal map, which is just pointing up, basically just the blue, then it will have no effect on the current object. So you can use that as an alpha texture to blend in and out splat mapping wherever you want it, and then use the multiple layers to paint whichever textures you want and have them blend into your main texture here. So there's a lot of potential to splat map little details onto instances of meshes with this, which I haven't really explored in the videos, and maybe I'll do that a little bit later. But yeah, I can easily paint whatever textures I want right onto this material from my MegaSplat texture library. We have some ice, and again, you can come in here and you can set the UV scale on the splat mapping to be different than the main UVs. So if I set this texture scale, oops, that's a little high, to 10 for both of them, then this texture is going to be much higher res, or much more tiled blended in there, and you can use the features of MegaSplat to create lots of variation there. So that's how you convert a model. If you Sometimes you'll have models that are right near the mesh limit, and then it'll run out of verts. So you'll have to go and split them up in Max or whatever, Maya, whatever you use. But that's all you have to do to convert the meshes. So now let's talk about texture arrays. So in the examples folder, under the textures directory, you'll see I have a ton of textures here. There's 60 different terrains, and we have a color map, a normal map, and then what I call an MSEO packing, and then the normal AO packing, or normal smoothness AO packing versions of all of these textures. And then what you have in the array folder here is texture array configs and the texture arrays that they generate. So if you look at the texture array in Unity, it's sort of missing a lot of detail compared to normal images in Unity. Normally when you click on an image in Unity, you have all these nice import settings, a preview of the image, etc., etc. Texture arrays have none of that really. They do give you some information about them. You can change like the filter mode or set the aniso level, etc. on them, but they don't have the nice inspector that you normally have. They also have no import pipeline. There's no way to natively import a texture array into Unity. So what I did was create my own way, and that is the texture array configure here. And so to create one, you go to create, and then you right click on this project window, you go to create, and then you go to MegaSplat texture array config. So I'm going to look at an existing one, and I'm going to close the cluster library for now. But what you'll see is you have this list of source textures. So what you do is you just drag all your textures in here, and one trick you can use is to lock the inspector so that then you can shift select a bunch of textures here and drag them in. So you drag all your diffuse maps, for instance, or all your normal maps into one array. Now everything that goes in that array must be the same size, the same format, etc. Set up all your textures the same. They should all be the same size. Don't have any settings different between them. Otherwise, it will throw an error. So once you have all your textures in there, you just hit update, and this will generate the array. But one of the problems you're going to face is that if you have normal textures and specular textures and all these different textures here, you're going to want them all in the same order. And so having to sit there and make sure that element 0 is the Cliff 01, that would just be horrible. It would take you forever. So there's a sort here, and if you click that, it will just sort these alphabetically for you. So basically you can drag all your normal maps, all your diffuse maps, each one into a texture config, hit sort, hit update, boom. Now you have texture arrays for everything. One thing you probably want to pay attention to, though, is linear. So if you have non-color textures, things like specular textures or normal maps, they should always be linear. So you'll notice if you click on any of the other ones here, like the normal, I have the inspector locked, that's why. So if you look at the normal one, you'll notice that it's linear. And that is very important because otherwise what it'll do is sort of destroy your normals. They'll point in different directions than you expect, and your lighting will not be correct. So very important when dealing with textures. So there's one other thing that is in this system. So when I close up that list of textures, what you have is a thing called the cluster library. And so if you look here, I have these textures named like Cliff 01, Cliff 02, and then I have like Grass 01, 02, 03. So if you name your textures like that with the sort of 01, 02, whatever numbering scheme you want to use, but if you name your textures like that, then you can just hit this button called Auto Generate Clusters. And what this will do is it'll find all those textures and it'll make little entries. And if you open up one of those entries, you'll see that this cluster has those two textures in it, and I could change those if I wanted to. I can select different textures. And then when you paint with this cluster, you're going to use a noise function. Okay, that means that it's going to sample the noise, which is a three-dimensional noise, and use that to choose one of the textures in this list. And you can have as many textures in here as you want. It will then randomize the textures as you paint, which is really nice. You can change the frequency and amplitude of that noise. So if I change the amplitude, you can see how the noise gets more contrasty or less contrasty. That's going to control the spread. So if you put the amplitude way up, then you're only going to get the top or the bottom texture if you had three. The other thing is you can change the blend center point. And so if you watch on the preview, you can see that that's going to push us more towards the middle, the edges, etc. of the texture. The final thing is the frequency, which is the size of the noise. The preview will not show you this because depending on the scale, you would end up not seeing anything in your preview, right? Because you'll end up with like one value for the whole thing if you have a noise that's too big. But generally, what I do is I fill an area of terrain or something, and I play with that setting until I get a good look. And usually, I just stick these at 1 and use the global controls for this. But if you want to adjust them all here, you can. Additionally, you can decide that instead of using noise, you want to use an angle. Okay. So if you use this, then it's going to choose between these only 2 textures here. If I had 5 in here, it would probably work better. But basically, if the angle is pointing down, then it's going to choose the bottom ones in this array. And if the angle is pointed up, then it's going to choose the topmost ones. So what you might do is basically have a brush set up that puts different textures on, on the cliff's edges versus the ground, and then you could fill the whole terrain and get a basic layout going really quickly. Additionally, you have this curve here, and what this curve allows you to do is bend that mapping. So if you want to bias it towards the lower ones or the higher ones or different angles, you can do that. And then finally, the last mode is the height mode, and the height mode is very similar. It has the biasing curve, and it basically just goes the bottommost ones to the topmost ones, physically in this list, not in the array order, but from the lowest point on the object you're painting to the highest point on the painting your object. So you can do things where up in the hills it's snowy, but down on the ground is grassy. So these are so there are some tools I've seen for doing this type of stuff that are really advanced and allow really deep arrays. I may add some of those things later, but this is a very simple form of that so that you can quickly make brushes. But I almost always use noise brushes and just paint because that's what I like to do. So there's the other stuff. You can delete this from the library. You can roll any of these up and you can create a new entry if you want to make your own custom entries with some angle or height data that's controlling what gets put where when you paint. So yeah, that's the texture array. Once you generate the texture, once you hit the update, it will generate a file that says MegaSplat diffuse, because that was the name of our config, with _t array. And anytime any of the textures in this change, or you switch platforms or anything like that, then it'll rebuild the arrays automatically. So this is great because it means if you switch over to iOS, it's going to update the texture arrays just like it updates the textures and keep everything in sync. And finally, there's one little other thing you'll notice sometimes is that I have a material here that uses MegaSplats, and this material has per texture properties on. It also has flow mapping and other stuff. But when that feature that brings up this editor is on, so that you can have different values here for each texture for different things, when that's on, what it does to store that information is it writes out a little 256 by 1D texture with the various information. So you can see that little dot there. Maybe you can see that in the video. But that dot is the fact that I have some texture settings on my ice textures here. So right there. So it basically just stores those in a texture because right now there's not a way to store arrayed information in a material in Unity. So yeah, so that covers basically textures. The only other thing to really talk about is your texture packing, which is something you want to decide up front. So let's talk about the 4 packing modes that are available. There's standard. Standard is the closest to Unity's. What it expects is that you have a standard normal map, you have a standard metallic specular map, which is basically the metalness value in the R texture, or in the R channel, and the smoothness in the alpha. And then you get a diffuse map, and the diffuse map in our case has the height map in the in the alpha channel, and that's basically it's not really useful to have that broken out into a separate texture. It would just make the performance worse. So that's one minor difference from sort of Unity standard shaders. They keep their height map in its own texture. There's the MSEO packing, and I've included textures in this package in MSEO format. What this is it's metal, smoothness, emission mask, and ambient occlusion. So if I go to one of those textures, let's look at the MSEO here, it mainly looks green, but if I switch over to the alpha channel, you'll see it has the ambient occlusion in there. And that's because this does not have emissive, so the emissive is black, and the metalness value is 0, so it tends to look green. The advantage of this is that what you can do is get a fully PBR surface with all the features. You get per pixel metal, per pixel smoothness, you get an ambient occlusion mask, an emissive mask, and then you can have your normal and your standard normal and your standard diffuse map with the height map in the alpha channel. So with 3 textures, you get every feature of a PBR. Now there's one limitation on this, which is that the emissive value is just a single channel mask, and what happens is it gets multiplied with the color value to produce the emissiveness. So for instance, if I look at this lava texture here, and we look, you can see the blue channel here is lit up, and so what it's doing is it's saying, okay, I'm going to multiply the output of this blue channel by the red color, which will make all of this red here emissive, right? So it's just a mask. You can't have it differ from the diffuse color. But for not having a whole other set of textures, that's a huge win. So back to our terrain shader, we have 2 more packings that are available. So the next one is the one that the example uses, which is called Normal Smooth AO. And so what that does is you have your diffuse map with your height value in the alpha channel, and then you have a texture which should not be set to normal map. It should be set to advanced and linear workflow. That is just the normal map's first 2 channels, so the red and the green from the normal map, and then you have the smoothness value in the blue channel and the ambient occlusion value in the alpha channel. So with this, you now only need 2 textures to get a fully PBR surface. You do have the option to have another texture for emissiveness if you really want that, but most of the time I don't have emissive surfaces, so this is a big win because instead of having 3 textures to sample, I only have 2. And then there's another variation on this which is very similar, except instead of ambient occlusion, it has per pixel metal. For the type of content in the example scene, there is almost no interesting metallic information. So that packing makes a lot of sense for terrains and stuff like that, the Metal Smooth AO packing. It gives you all the best things of a PBR shader with less textures. So while we're on the topic of textures, I'm going to briefly touch on performance. The performance of these shaders is mostly going to be bound by memory bandwidth and then the number of samples. So when a GPU samples a texture, it is not a linear cost. Something that takes 2 samples is not twice as expensive as something that takes 1. Generally speaking, if you resample the same texture, it's going to be cheaper than sampling another texture. But to some degree that depends on whether the section you're sampling is in the cache, right? If it's in the active memory. So if you're sampling really different areas of the texture, it may be slower. The MegaSplat shader does a lot of samples, so that tends to be the bottleneck. And so if I turn off some of the more exotic features here, just to get it down to a basic, here what we have is a basic terrain shader. We have a macro diffuse texture over the whole thing. And then we have the metal and smoothness ambient packing, which means that our texture arrays, we just have 2 texture arrays. We have one for the albedo and height map, one for that normal plus smoothness plus AO texture. So that is basically the minimum PBR that we can really get it down to with a macro texture. If we turn off the macro texture, we're going to have a little less to do. This is a 2-layer shader. There's a 1-layer shader available as well, which is going to be even cheaper, but I really love having the ability to blend textures together partially, so I favor the 2-layer shader. And what you'll notice is that this takes 12 texture samples on the texture arrays, and then it does 3 regular samples. Although this, now that I think of it, might be incorrect. I think it's only doing 1 here because it's only sampling the macro texture. So I have a little bug in my calculations there. But anyway, so to compare this to a standard splat map shader, if you were doing Unity's four terrain splat maps, and you basically had a normal map, a color map, and then you had the height map, and then you had a specular metalness map. You would have 4 samples for each layer that's being splat mapped. So with 4 layers, that's 16 samples that you're going to perform. So this shader is actually going to be cheaper than that. It's only 12 samples plus I'm doing the macro texture, which is 1 more. So in many ways, this can outperform traditional splat map shaders and still gives you hundreds of textures from your texture arrays. So I think that about covers it for textures, how to deal with them, what your authoring sort of options are. And if you have any questions, shoot me a message and I'll be happy to answer. Thank you.